Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today I'm going to talk about trigonometric ratios. Okay. Trigonometric ratios are always defined in terms of a right angle triangle. Suppose this is the right angle triangle ABC, where angle B is at right angle. Whenever we talk of trigonometric ratios, first thing which we need to look at, what is the angle of reference? The angle against which we have to find the trigonometric ratios. In this case, consider angle C, which is theta, is the angle of reference. Now, the side opposite to the angle of reference is perpendicular, and side connected with angle of reference, that is adjacent to the angle of reference, is base. The side which is opposite to the right angle is hypotenuse. So this understanding you should have very clearly embedded in your mind. First, what is the angle of reference? The side opposite to the angle of reference is perpendicular, side adjacent to the angle of reference is base, and side opposite to the right angle is hypotenuse. Okay. Now, per definition, the sine of theta is equal to perpendicular by hypotenuse. Perpendicular by hypotenuse. Cos of theta is equal to base by hypotenuse. Okay. And tan of theta is equal to perpendicular by base. Okay. Then there are three other ratios. One is cot theta. Cot theta is just inverse of tan theta, that is base by perpendicular. Then sec theta is just inverse of the cos theta, that is hypotenuse by base, and cosec theta is equal to hypotenuse by perpendicular. So these are trigonometric ratios defined in terms of angle theta. Okay. Also keep in mind that in the context of right angle triangle, the other two intervening angle is always acute angle. So therefore, all these ratios are predominantly defined for acute angles. Okay. Now, let us look at finding the trigonometric ratios of standard angles like angle 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. And we will take the help of geometry to really identify the values of these ratios for standard angles. Let's start from theta equal to 0 degree. So let's draw that rectangle again, triangle again, that is A, B and C with angle theta, and because theta is the angle of reference, so this is perpendicular, this is base, this is hypotenuse. Okay. Now, if theta is 0, it means that you are reducing this side and bringing it closer to the base. Then only theta will reduce. You reduce it further, you reduce it further, you reduce it to the extent that this side AC just becomes equal to the side BC. If that happens, then what happens about the perpendicular? As you can notice, the perpendicular becomes equal to 0. This side just gets closer and closer and closer. So the height of this side AB becomes 0, so perpendicular becomes 0. And whatever be the base, that becomes equal to hypotenuse, and that may be we can say as BC. Okay. So with this, let us try finding out sine 0. Sine 0 degree will be perpendicular by hypotenuse. But as we know that perpendicular has become 0. So 0 divided by hypotenuse. 0 divided by any number will be 0. That is how you see sine 0 is 0. Right? Now let's talk about cos 0. So cos 0 degree will be equal to base by hypotenuse. Right? Base and hypotenuse in this case becomes equal, that is BC, whatever be the length of BC. So it will be by, again h is also equal to b, and therefore b and b becomes 1. So that's the reason you get cos 0 equal to 1. What about tan 0? Tan 0 degree will be perpendicular by base. In this case, perpendicular is 0. So 0 divided by whatever be the length of the base, 0 divided by any number will be 0. So likewise you get 0. Okay. Also, you will see a pattern, and just for convenience I am writing it here, is that tan theta is p by b and cot theta is base by perpendicular. So just inverse. So you can write cot theta is equal to 1 upon tan theta. Similarly, cos theta is b by h and sec theta is h by v, just inverse of it. So we can write this as 1 by cos theta. Likewise, cosec theta is h by p and sin theta is p by h. Therefore, cosec theta is 1 upon sin theta. Now, if for 0 degree you have to find out cot theta will be 1 upon tan theta, which is 1 upon 0. Now, anything divided by 0 is undefined. Okay. Similarly, if I have to find sec 0, then it will be 1 by cos 0. Cos 0 is 1. 1 by 1 is 1. Okay. Likewise, cosec 0 is 1 by sin 0. Sin 0 is 0. So 1 by 0, anything divided by 0 is undefined. So that's how you get all the ratios of 0 degree. Okay. Now let's go ahead. So this was about all the ratios of 0 degree. Okay. Now let's go and find the ratios of 30 degree and 60 degree. Theta is equal to 30 degree or theta is equal to 60 degree. Let us discuss both these cases. For both these cases, we take the help of, again, geometry. Let us draw a equilateral triangle of side 2a. This entire length is also 2 times a. Let us draw a perpendicular on the base. If it is A, B and C, let's draw the perpendicular. So we know that if it is an equilateral triangle and you draw a perpendicular, then the base will be divided equally. So therefore, this becomes A and this portion also becomes A. Now because this is 90 degree, let us give it a name like D, this point. So triangle ABD is a right angle triangle. Okay, is right angled triangle. Okay. Also, we know that because it is an equilateral triangle, so all angles will be 60 degree. So this angle is equal to 60 degree. Now because this angle is 60 degree and this is 90 degree, so therefore naturally this will be 30 degree, because sum of the three angles in a triangle has to be 180 degree. Now let's try finding out the trigonometric ratios of 30 degree. To do that, let us first find out the length of AD. Now if you look at AD, the length of AD, and you consider this a kind of right angle triangle, because this is 90 degrees, so this will be a hypotenuse. Okay, so therefore AD, depending upon whether you take this angle or this angle, it will be either base or perpendicular. But then value of AD will be the hypotenuse square, that is 2a the whole square, minus this side a square, which will be root of 4a square minus a square, which will be root of 3a square, and that can be written as root 3a. Okay, so that becomes your this length AD, that is root 3 times a. Okay, now let's try finding out the ratios. Sine, let's start with 30 degree and sine 30. Sine 30 will be perpendicular by hypotenuse. Now what is my angle of reference? My angle of reference is this 30 degree. So what will be my perpendicular? My perpendicular will be this side, opposite to the angle of reference. So perpendicular is A, and what is my hypotenuse? 2a. So a cancels, this becomes 1 by 2. So sine 30 degree is 1 by 2. If you look at sine 30 degree is 1 by 2. Let's talk about cos 30 degree. Cos 30 degree will be b by h. What is base in this case? Because angle of reference is this, so base is root 3a, adjacent to the angle of reference, divided by hypotenuse, which is 2 times a. A cancels, this becomes root 3 by 2. Okay, we got cos 30 degree is equal to root 3 by 2. What about tan 30 degree? Tan 30 degree will be equal to perpendicular by base. Perpendicular is how much? Opposite to the angle of reference is a, divided by base. Base is root 3 times a. A cancels, and therefore this becomes 1 upon root 3. Tan 30 degree is 1 upon root 3. Likewise, you can find cot 30 degree, which is 1 upon tan 30 degree, is root 3. It's just inverse of that. This entire, all three you can find out. So that becomes the trigonometric ratio of theta equal to 30 degree. Sine, cos, tan you can get, and you just inverse, you will get cot, sec and cosec respectively. Okay, let us talk about the next angle, which is 60 degree. So for 60 degree angle, let us look at how do we handle that. Now this becomes my angle of reference. So opposite to that, this becomes now perpendicular, and this side BD becomes my base. Now sine 60 degree, if I have to take, then it will be perpendicular by hypotenuse. What is my perpendicular? Because this is angle of reference 60 degree, so opposite to that will be my perpendicular. So this will be root 3 times a divided by, what is my hypotenuse? 2a. A cancels, it is root 3 by 2. Sine 60 degree is root 3 by 2. Okay. Likewise, cos 60 degree if I have to find, then this will be equal to base by hypotenuse. Cos theta is defined as base by hypotenuse. What is my base? If it is angle of reference, my base is A and side adjacent to this angle, and hypotenuse is 2A. So A cancels and it is 1 by 2. Cos 60 degree is 1 by 2. Okay. What about tan 60 degree? Tan 60 degree. This will be equal to perpendicular by base, right? What is my perpendicular? My perpendicular is root 3A. What is my base? My base is A. A cancels. This becomes equal to root 3. Tan 60 degree is root 3. Now to find cot theta, sec theta, cosec theta, you have to just do the inverse. Cot theta is 1 upon tan theta. That's how you get cot 60 is equal to 1 by root 3. And likewise others also you can get. So that's how you calculate 30 degree or 60 degree trigonometric ratios. Now let's find out how do we do the values of trigonometric ratios if theta is equal to 45 degree. Again we will take help of geometry, and this time we will get a right angle triangle, isosceles triangle with base and perpendicular being same A. So if you have an isosceles triangle which is right angle triangle and your perpendicular and base, supposing I am getting this as a reference angle, then this is perpendicular and this is base. So if that is the case, then the hypotenuse will be opposite to 90 degree angle will be this. What will be the value of AC from Pythagoras theorem, which is H? This is perpendicular, which is A, this is base A. So hypotenuse will be equal to A square plus A square, which is root of 2A square, which is equal to root 2 times A. So this becomes the length of the hypotenuse. Now let's try calculating the values. Now sine 45 as per definition will be equal to perpendicular by hypotenuse. What is my perpendicular in this case? If this is the reference angle, which is 45 degree. It's important to understand that because it is isosceles right angle, therefore these two angles will be equal. Because this is 90 degrees, so this will be 45 and this will also be 45. Okay. So now we take sine 45. Because I am taking this as a reference angle, so this becomes my perpendicular. So this will be A divided by hypotenuse, which is root 2A. A cancels, so this becomes 1 upon root 2. Sine 45 is 1 upon root 2. Okay. Let's talk about cos 45. So cos 45 will be equal to base upon hypotenuse, and our base is also A. Hypotenuse is root 2A, so A cancels, this becomes 1 upon root 2. Okay. Let's calculate tan 45. Tan 45 is equal to perpendicular by base per definition. Tan theta is perpendicular by base. My perpendicular is A, my base is also A cancels 1. Tan 45 is 1. Likewise, you can get cot 45, just inverse of this, sec 45 and cosec 45 also. So you have the clarity how to calculate the trigonometric ratio of 45 degree. Let's talk about the last one remaining, that is 90 degree. So if we consider the angle to be 90 degree, so if this was the right angle triangle ABC and this is the reference angle theta, what we do? Theta, if we keep increasing, in case of 0 we were trying to decrease. If we keep increasing theta, then suppose, let's take the example that this is 45 degree. So if I increase this angle, this will increase. Likewise, if I increase it further, it will further increase, right? And you see that this projection, that is base, will continuously decrease, right? So if you keep increasing, ultimately your base will keep shrinking to the extent that base becomes 0. And this side, which is hypotenuse, that hypotenuse will become equal to or parallel and equal to the perpendicular. This is perpendicular, this is base, this is hypotenuse. Correct? So in this case, base becomes 0 and your perpendicular will become equal to hypotenuse. Now let us talk about sine 90. So what happens? Sine 90 degree will be equal to P by H, but P and H becomes equal, so therefore P by P cancels, so this is 1. So sine 90 is 1. Let's talk about cos 90. Cos 90 will be equal to base upon hypotenuse, but in this case, because the base was shrinking, so ultimately base becomes 0. So 0 upon whatever hypotenuse it is, that is equal to perpendicular. So any number, 0 divided by any number will be always 0. What about tan 90? Tan 90 degree will be equal to perpendicular by base. What is the value of perpendicular? Perpendicular is equal to hypotenuse, let's keep it as P. What is base? Base is 0. Any number divided by 0 is undefined. So therefore tan 90 is not defined. Similar way you can get cot 90, sec 90 and cosec 90 by inversing them accordingly with this relationship. So with this set of explanation, you might have understood what is the basic definition of all 6 trigonometric ratios and how to find the value of these trigonometric ratios for standard angles. I hope now it is very clear to all of you. Thank you very much.